Hello everyone, today I want to explain homework 9.1. Consider the electrical circuit shown in figure below. The circuit consists of an induction, a resistance, and a capacitance, finding a relationship of the transfer function. The presentation will follow this structure. First, I will state the problem clearly, then analyze the circuit components, divert the transfer function step by step, summarize the key knowledge points, and finally conclude with a summary. The problem is straightforward. Given this RLC series circuit, we need to determine the transfer function, which is the ratio of the output voltage across the capacitor to the input voltage source. First, let's analyze the circuit components. We have a resistor, inductor, and a chapter in series. Each component has a specific impedance in the statement, which is critical for our analysis. The resistor has a constant impedance R. The inductor has an impedance of SL, and the chapter has an impedance of 1/SC. To divert the transfer function, we start by applying king of voltage law in the time domain. This gives us the equation. The input voltage equals the sum of the voltage drops across the resistor, inductor, and the chapter. The voltage across the chapter is also defined as the integral of the current divided by the chapters. Next, we convert this time domain equation into the domain using the Laplace transform. This simplifies the difference and the integer equation into algebraic ones. The transformed equations are shown here, where the derivative becomes multiplication by s and the integral becomes diverse by s. Now we substitute the expression for Is from the chapter voltage equation into the KVL equation. After Reynolds and factoring out VOS, we can solve for the retail VOS or VIS, which gives us the final transfer function 1 over LCS squared plus RCS plus 1. The key knowledge points used in this derivation include preferred voltage level, the Laplace transform technical understanding impedance in the S domain for its component, and the definition of a transfer function itself. In conclusion, I have successfully driven the transfer function for the giving RLC service circuit. The process demonstrates the application of fundamental circuit law and the Laplace transform method to analyze a dynamic system. The transfer function of the RLC series circuit has been successfully derived as Hs is 1 by Lc as 2 power plus RCS plus 1. The process involved applying KVL in the time domain, performing Laplace transform to convert to the S domain, and solving the results algebraic equation to find the relationship between the output and the input voltage. This is my homework 9.1. Thanks for your listening. See you.